Related rates. Our objective is to use the derivative to solve problems involving rates of change of variables that are related. Related rates are rates of change of variables that are related, usually with respect to time. For example, find dx dt, the derivative of x with respect to time, when x equals 3, y equals 4, and dy dt equals 2 for x squared plus y cubed equals 1. Notice that we're taking the derivative of x with respect to t. So that means we want the derivative with respect to t of the left side of the equation, x squared plus y cubed, and the derivative with respect to time of the right side of the equation, 1. When I take the derivative of x squared, that is 2x, and I need to use the chain rule because that's a different variable, so I say times dx dt, plus the derivative of y cubed, 3y squared, times dy dt. Again, t is a different variable, so we use the chain rule. Equals, 1 is a constant, so that derivative is 0. Now I'm asked to find dx dt, but I know all these other values. So now I substitute those values. X is 3, so that's going to go there. 2 times 3. Dx dt is what I don't know, so that will stay dx dt plus 3 times y is 4, so 4 squared. Dy dt is 2 equals 0. Getting dx dt by itself, I get negative 96 divided by 6. That's an example of a related rate that's already set up for us. Now, usually, we're going to be applying related rates to situations. So we're going to be given situations with words, sometimes in a paragraph, asking us to solve a certain problem. It's usually easier if we can dissect the problem a piece at a time. So let's try to follow these steps for solving a related rates problem. First, read the problem carefully. If it's possible, draw a simple picture. You don't want anything very artistic, creative, just something simple that might show the shape that's going on in the scenario. 2, note things like the find when given. I'll explain what that is as we go through problems. From the problem, identify any variables or constants and label the picture with those. The more we have labeled in the picture, the less we have to deal with the words. Write the units as much as we can. And remember that when we see the word rate, we want to think derivative. Rates equal derivatives. Next, write an equation relating the variables and constants that you wrote down and labeled in your picture. Then, because it's with respect to time, we will differentiate both sides with respect to time, taking the derivative with respect to t. Finally, we'll plug in the when and given to solve for the find. Let's see how these work.